So what we're going to do is we're going to look at your sheet, and I'm going to look at number 2, problem 2, and if I can get this. So notice that, and before I do it, I just want to make sure, this thing is called the rectangular coordinate system. Everyone familiar with that? Anyone not? Rectangular. Sometimes you will have heard it Cartesian coordinate system. Anybody heard it called that? Cartesian coordinate. Same thing. Cartesian or rectangular. And what that means is that the plane of it's a two-dimensional, so it's not three-dimensional, it's just two-dimensional space, and then it's that plane, and that plane of that blackboard is a plane that extends theoretically out in all directions, right? And what you do is you establish in that plane, and what we've established is that this particular point right here is the origin. So in terms of the x-axis, that's this axis right here. This is going to be 0 on x, and it's going to be positive going in this direction, and it's going to be negative going in that direction. Now you can use those vertical lines to be whatever you want. You can use this distance as 1, negative 1. You could use this distance as negative 1, or you could use this distance as negative 1. But once you establish a certain length, then you just continue on with that length being units, right? And then you go positive, going the other way. Now, the quadrants that you have here is this is first quadrant, second quadrant, third quadrant, and fourth quadrant. Now, that same point right here for the y is the origin for the y, but now positive on the y is measured in this direction, and negative on the y is measured this way. And the y value is always the second of the two values in an ordered pair. So you count up or down. In the same way, you can count what you do is you establish some unit length and call it 1. And then you just keep on going up or down. Now, this Cartesian coordinate system or rectangular coordinate system, you can use it whatever way you want, and you will use it differently depending on what your application is. Now, if you were talking about relating hours of driving to distance at a constant rate of speed, would you ever drive negative hours? Well, hours would be the independent variable, and you'd usually have them on the x-axis. So what you'd do is you'd move this origin clear out over here and put it here, because you would only need the first quadrant. Because hours, you would always go positive number of miles, right? You'd never go negative, right? So you'd essentially move that origin right down here, and you'd have first quadrant, right? And that's all you'd use. Now, on the other hand, if you were saying, I'm going to say how many feet am I going out on a body of water and how deep is it, then what would you do with this origin? You'd always go positive because you would never go negative, right? You never go back up on the ground, you'd go out. So you'd move it back here, right? But now, what would you do? You would move it up here, have the distance out you go, and the distance down you go, and you'd have fourth quadrant, right? That's the only thing you'd look at. Correct? So you'd use that and it'd still be the Cartesian coordinate system. It'd still be, you've established in your graphing what it is. Now let's say that you were going to graph the temperatures in the wintertime over a course of a month. Now then, what would you do? Your time would always march forward, wouldn't it, in a month? So you'd move that origin back where? Back here, and then you'd establish this kind of a thing, and you'd use what quadrants? First and fourth quadrant, right? Because you'd either have a positive temperature or a negative temperature. Correct? Are you with me? The Cartesian coordinate system is not always just an X in your face. It depends upon what your application is. You understand what I'm talking about? So that's the application of what we're dealing with, and we're just finding points in that system. How many people are with me? How many people are following what I'm saying? Okay. I want you to understand it's an application that we're talking about. We're going to go with an understanding of how to plot, but you're going to be applying this stuff, and you're going to be looking at, newspapers or whatever it is that use graph, and they'll use it in those ways, but it's still the rectangular coordinate system that they're establishing. And who knows, I don't know what field you're in, but you have to be plotting data someplace. And just set your system up that you use the least amount of paper and space, and it reflects the information that you want. And then use whatever one of those quadrants that is consistent with the data that you have. Good with that? Any questions? You guys behind there are going to have to raise your hand and wave it. Okay, what I want to do is number 2. Number 2 says graph these points. The first point is graph 5 minus 1. So what are we going to do? We're going to start out right here at the origin, and we're going to go 5 which direction? To the right on the x-axis, right? Now 5, you see, we don't have enough room to do 5s, or maybe we do. If we do this, then 1, 2, 3, 4. We got enough that we can use those big ones. We can call 1, 2, 3, 4, 5. Now, if I had 10, what would I have to do? I'd have to break it. I'd have to. If I had 10, then if that were 10 minus 1, then I would have to count where? I'd have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I wouldn't have enough room the other way, would I? You just have to establish whatever unit you want, right? That's what I'm trying to tell you. Correct? All right, so we're 5 minus 1, so let's go back to the black. We're 5 out, and that got me to here, right? Got me right to there. And then we're which way? Down 1. So I'm using these units, so I'm going to be right down there, right? And I would say this point is what? 5, comma, minus 1. I could also go down here minus 1 like this, over here to 5, and drop an intersection at that point. If that helps. Or confuses you, whichever. Okay, let's go minus 3, minus 3. Now we can use those big red squares, can't we? So we would go minus 3. This 3 tells us to move what? Left. So I'd go 1, 2, 3. And this 3 tells me to move down. So I go, like I said, I can just go down like that. And that point, this point is right up here. That point is what? Minus 3, minus 3. You know, I also could go out here and do this. I could say, this is x is minus 3, and this is y is a minus 3. I can, everything is, and then I could find the intersection point. Whichever way I'd want to approach it. I could count 3 down here, and then 3 out this way, and get to the point. You don't need to do anything else. That should be enough, huh? All right, the next group of problems, 7 through 12, is, and I'm not going to use that graph. I'm just going to say, okay, we're going to do 8. And 8, point A, and we want to say what is the x value and y value for point A. So what is going to be the x value? 0. Everyone agree? So it's 0 for x. What's the y value? 2. Okay. So does 0, 2 identify A? Okay, B. Okay, B says x is, and I heard someone say a -4. Does everyone agree? All right, what is y? I heard -1. Everyone agree? Anyone disagree? C, what is it? X is 2 and y is? Everyone agree? I don't like that screen in the way because I can't see you guys. I usually look at people's faces and figure out, I can figure out whether they understand. D, what do we got? X is 1 and y is -3. Is that right?
Yes.
Do we need to do any more? Everyone good with that? All right. Let's look at 14. It says draw a line through all points with the abscissa -1. Okay. I'm not going to use that terminology, but the ordinate and abscissa are 2 different values. The ordinate usually is the x value, and the abscissa is y. But I'm not going to use that terminology. If I give a problem like this, I will say y is -3. That kind of a problem, 14, I would say y equals -3. Line through all points with the abscissa 3. So what's going to be that line? Okay, so if I go back to y is -3, so I go 1, 2, 3, right? All points that go through this right here that have that. So what it is, if I can get is that all points that have y equals 3? If I do this to it, right? That means the line just goes on forever, right? Okay. So we should be able to do problems 1 through 16. I've used up my time. Yeah. Okay.
Okay, so on the answer sheet for number 13, is on the,
X-axis? Okay. That's why I'm not going to use abscissa and ordinate. I will not say abscissa and ordinate. Abscissa apparently is the X and the ordinate is the Y. I won't use, what?
okay, so what is, so.
Do you know what I forgot to do is record this?
So abscissa is the X then, not the Y?
Apparently. I would have to look at it. I never use the terminology, so I'll look it up. I will not use it. The first number in the ordered pair is abscissa. The X is the abscissa.
Okay.
So if it were,
So the 14th order, so you just did the order.
I did the ordinate. But I'll tell you this, I will not use it, because that's how come I made the mistake. I don't use abscissa and ordinate. And so problems, these particular problems where it says abscissa and ordinate, I will not use that terminology. I will say all values that have X, or all values that have Y. Thanks for that correction. But you know what? I want you to know something here. The thing that you have to make sure, and I think I got a recording from the last class, but you've got to help me do this. I have got to, at the beginning of class, we're going to make a recording. You see this icon right there? What I got to do, all right, here it is down here. I guess I didn't record it, so that was there.
Push the stop button.